next time. But it might be the time after that. It's so organized.
No, I
Okay?
took it.
So, we finished problem number 6 last time. I want you to look at that big circle that's drawn on there. We talked a little bit,
It's great.
very, very little bit, about this circle the other day. Remember, there were some angles that we drew a circle for because we couldn't make a triangle? And I said I like to arbitrarily let the radius be 1 because that's like the easiest, nicest number in the world. And that's called a unit circle. Well, that's what they drew here. Can you tell the radius is 1? See those points? 1, 0, 0, 1, right? Now they have also labeled a bunch of other points. We haven't done a ton of this, but I want you to look at those ordered pairs around the outside of the circle. Do numbers like root 3 over 2 and 1/2 and root 2 over 2, do those look familiar? Aren't those the numbers we get when we find the sine of 60 degrees, for example? So they have labeled for you as a reference, and some kids memorize it. That's up to you. I do not memorize it. I figure them out with 30, 60, 90 triangles. But here's the deal. An angle of 30 degrees is pi over 6 radians. Does that make sense to you? Pi is 180, right? So 30 is a sixth of that. So pi over 6 is 30 degrees. And the ordered pair associated with that, I'm not going to draw that whole circle, but here's my 30-degree angle. I know that this would be root 3, excuse me, this would be 1, this would be root 3, and this would be 2. Now that is not, if I do a circle, that is not a unit circle, the radius isn't 1. But if I make the radius 1, shrink it, this ordered pair is root 3 over 2, comma 1/2. Does that make sense to you? That's x and y for this particular angle? Now, what's cosine? Cosine is x over r. Well, if the radius is 1, then isn't the cosine just x? Cosine is x over r. If the radius is 1, then the cosine is just x. So what this circle gives you is the cosine and sine for all of your special angles. This is 30. They do the same thing for 45 and 60 and 90 and 120. All of them are there. All of them are there. Notice there's a definite pattern. Would you agree with that? Definite pattern. Notice some of them are negative. Why would they be negative? Because they're in a quadrant that has either a negative x or a negative y, or both, right? Quadrant 3, they're both negative. But that's what that triangle is. Or that triangle, that circle, this is a circle. That's what the unit circle is. It is kind of a, I don't know, I want to say like a cheat sheet for all of the sine and cosine values for the special angles. Okay? Use it however you want to use it. I'm never going to give you a quiz. Oh, Mr. Knoll, remember Mr. Knoll? He used to give timed quizzes over this, so you had to have them all memorized and snap through them. I'm not doing that, but it's there. If you're a memorizer, memorize it. For what it's worth, it's there. Okay, now number 7. I'm going to try not to use my circle. I know I shouldn't have put it on this same page. I should have put it somewhere else. But I'm going to try not to use the circle. I'm going to try to figure this out. Find the value of the unique real number theta between 0 and 2 pi. So theta is between 0 and 2 pi, which means that it's in 1 revolution. I'm not going to be doing any of that spinning stuff that I did yesterday. 1 revolution. And the sine is 1/2. And the tangent is negative. It's negative, yeah. And I'm trying to figure out what the angle is. What angle has a sine of 1/2? Well, think about that for a second. If the sine is 1/2, doesn't the triangle have to look like that? Those are special. What would this one be? If the hypotenuse is 2 and that's 1, isn't this root 3? How big is that angle? Ooh, 30 degrees. I'm supposed to be in radians, so 30 is a 6.
Pi over 6.
Pi over 6. So the answer to the problem is not pi over 6. Because why?
Tan has to be negative.
Tangent has to be negative. Okay? Now, if I draw a triangle over here that has a sine of 1/2, isn't this angle still pi over 6? Is the tangent negative? Yes. So there is a picture of one possible answer. But here's the problem. The angle must be measured in standard position. So the angle isn't pi over 6. This is the angle. Because it has to start on the positive x-axis. So what would it be?
150 degrees.
What?
150 degrees.
Well, in degrees, it would be 150. I'm supposed to be in radians. So how did you get 150, Oliver?
Because if 180 is a straight angle,
Wait, so you did the math. You said 180 minus
30.
Okay, I'm in radians. So I'm not going to do 180 minus 30. I'm going to do pi minus pi over 6. Won't this angle be pi minus pi over 6? Which is 6/6 minus 1/6. So that blue angle is 5 pi over 6. Would you agree with that? 5/6 pi. Now, here's the deal. Is that the only possible answer? Because trigonometry is full of multiple answers. Remember all those loops and positive, there's always the chance of multiple answers. Could I have built this triangle down here in quadrant 3? Now, the sine 1/2, oh wait a minute, would the sine be 1/2 down there in quadrant 3? No, it would have to be negative 1/2, so that won't work. That triangle won't work. How about in quadrant 4? Nope, that won't work either. So guess what? The only answer to the problem is 5 pi over 6. 150 in degrees, but 5 pi over 6 in radians. They asked for it in radians. Okay? It's like a big puzzle. There's so much to think about. All right, one more. It says the tangent is -1. The tangent is -1. And the sine is negative. Let's think about, before I start drawing a bunch of triangles, where would that happen? Well, first of all, I don't care. Where's the sine negative? Sine is y.
When it's on
Sine
one.
is y. So its sign is negative in quadrant 4, and it's also negative in quadrant 3. Those are the only two places that sign is negative. Remember, sign is y. Sign is y over r. Y has to be negative if the sign is negative. And y is negative down here. So your two possibilities are down here. In this quadrant, aren't both of these negative? So tell me what happens to the tangent in quadrant 3. It's positive. I need it to be negative, so this isn't gonna work. It's gotta be that one right there. Are you following along my deduction here? Now, if the tangent is 1, doesn't that mean these have to both be 1s? 1 over 1? Or 2 over 2, or 5 over 5, whatever. And if those are both 1s, then this is a 2, and that one's a negative. Now, how big is this angle?
45 degrees.
45 degrees. So wait a minute, we're in radians. So 45 is what fraction of 180? A fourth? So this is pi over 4. Now, pi over 4 is not the answer. You could say negative pi over 4, except these are the directions. So guess what? Negative pi over 4 isn't the way they want you to write the answer. They want you to give me this answer. I'm going to emphasize negative pi over 4 is an answer to this question, but not in the range they want it. They want it this way. So what would that orange angle be?
3 pi plus something.
What? 7 pi over 4. That orange angle is 7 pi over 4. How did Peter get that? Well, first of all, let's do it in degrees. If you had this situation and you knew this was 45 degrees and I said, what's that? What would you do? 360 minus 45, right? Easy. But I'm in radians. So instead of using 360, I have to use 2 pi. So 2 pi minus pi over 4 is 8 fourths minus 1/4, which is 7 fourths.
Wait, so we did pi for that, just that one, not 2 pi because it's just 180?
Mm-hmm.
And then that one is because it's the whole?
Yeah.
Okay.
Yeah, it all makes perfectly good sense. And we don't memorize that, Lucy. We kind of just, yeah. Halfway around's pi. Okay. All right, that takes care of that. Let's see, there's one more I want to do. Manufacturing swimwear. The monthly sales they give me an equation. The monthly sales X in thousands for Get Wet swimsuits are modeled by this equation, where T represents the number of the month. Are you reading that the way I am? Okay, before we do this, I want you to think about this problem. And it could totally be made up, but it makes sense. What does a sine equation, this is a sine equation, and it's got a bunch of stuff in it. But basically, what does a sine equation look like? Like this, right? So what they're telling me is that if I plot my sales every month, it's kind of going like this. Does that make sense for swimsuits?
Yeah.
It sure does, because we're going up in like May and June, whatever, we're going up at Christmas time when people are buying presents and going to Florida and everything else. I mean, yeah, it's very cyclical, very cyclical. All right, well, let's answer the question. Estimate the number of get wet swimsuits sold in January. So we need P equal 1. What would April be? 4 and 6. And, oh gosh, October is 10. And, all right, so let's practice typing this in on our calculator. First of all, let's press mode before we do anything else and make sure our calculator is set out in radians. Absolutely, we're gonna be set in radians.
Should we,
So,
should we leave it in radians?
we're in radians.
Should we leave it when we're doing like everything else, or do we need to change it back to degrees?
You can do whatever you want. Now, be careful. I mean, mine's in radians from whatever the last time I used it. But if I have one of those problems like we're in my homework, well, it won't work like that. But where I'm solving the triangle and this is 48 degrees and I have to find x, I need to be in degrees, right? Leave it however you want. Get in the habit of when you turn it on, checking, and then resetting it if you need to. All right, so I'm gonna put in 1 for t. So I'm gonna type in 72.4 plus 61.7 sine pi divided by 6. Use your pi button, divided by 6. Did you get 103.25? So that would actually be 103.25 thousandths. So that would be whatever, 103,250. All right, go ahead and do, let's share the wealth here. Sammy, would your row do 4? Would you guys do 4? Chris, you guys do 6. Peter, you guys do 10, and I'll do 12. So we'll have all the answers. I bet this one was 72.4 also.
Yeah, 18.
Anybody, you guys, Sammy, what did you guys get for 4?
125,000.
So 125. And what'd you guys, who did 10? What'd you guys get? 18.97. And those are all thousands. I didn't write them all out in thousands, but there they are.
Can we answer the
Okay.
question?
So definitely we're fluctuating, going up and down. For which 2 of these months are sales the same? June and December. Now, from a practical standpoint, I'm not sure, because I thought those would be the most. But maybe by June you've already bought your bathing suit?
I'm surprised that January. Yeah, I would think April would be the most. You're like
April is the
anticipating.
most. But,
I'm surprised that January's so close.
yeah, me too. Not sure unless, I don't know. Anyway, from a mathematical standpoint, why do these 2 match?
Equal distance.
Think about what happens in the equation. If you put a 6 up here, you have 72.4 plus 61.7 sine. You put a 6 in there, won't this just be pi?
Yeah.
Now think about where pi is. This is pi over here. What are the coordinates of that point? -1, 0. Which variable is sine associated with? X or Y? Y. And Y is 0. The sine of pi is 0. So basically, this disappeared, and that was what we had. Now, what happens when we put 12 in here? Then it's 2 pi. Well, where's 2 pi? Over here. But isn't the sign still 0? So at those 2 places, the sign value was exactly the same. So the arithmetic, of course, came out to be exactly the same. Okay. All right. Well, that's interesting as heck. Let's stop there. And all I'm going to do is, what I want to do is just say this. Find a problem somewhere, whether it was in homework or notes, that you really feel a little fuzzy. What in the world?
It was, yeah,
What in the world? That we feel a little fuzzy
Yeah,
on.
that's where.
And let's do a quick little review before we start in with 4.4. Dom,
4.1, number 8.
you're talking about homework?
Yeah.
Homework 4.1, problem number 8. All right, so guys, please be respectful. You may not have a question about this, but somebody does. We'll get to your question in a minute. Please be respectful. Kathy races on a bicycle with 13-inch radius wheels. When she is traveling at a speed of 44 feet per second, how many revolutions per minute are her wheels making? Well, every time I do one of these, Dom, I start with what I'm given, which is 44 feet per 1 second. And then, I keep track of what I'm looking for. I'm looking for revolutions per minute. So somehow I have to get from these units to those units. And we talked about this, I think, in another chapter, that the big thing, the big move, is to get from revolutions to distance and vice versa. So what do we know about the distance of a revolution? It's a circumference. So 1 revolution is a circumference, which for this wheel is 26 pi inches. Does that make sense to everybody? 2 pi r? So 26 pi inches. All right? Now, I've got my revolution. I need to get rid of all this other crap and end up with minutes. So I can do that. I know 60 seconds are 1 minute. So now, Dom, I have what I need, and it's just a matter of getting rid of the other stuff. So, seconds are gone, so that's already gotten rid of. What do I know about inches?
12 inches in a foot.
12 inches in 1 foot. So that takes care of the inches and the feet. I think I'm done. Now, when you type this in, please be careful. I don't know how you do it. I type in all the numbers in the top. So I've got 44 times 60 times 12. That's my top number. Now, when I divide, the only thing I'm dividing by is 26 pi, but that's 2 things. So divided by, parentheses, 26 pi. And our answer is 387.85 revolutions. Got it? Okay. Lucy?
Can you do 4A on 4.1?
4.1. 4A. I'm missing information. Anytime I see a problem like this, arc length equals radius times radians pops into my head. That's what pops into my head. Every time I see a problem involving an arc length. Now, Lucy's gonna like shoot herself here because this is so easy.
Is it just 16 equals 1.4R?
Yeah.
Alright, never mind.
Arc length is 16. Don't know my radius, but my angle is 1.4 radians. Now, there was somebody in here this morning saying, how do you know it's radians? Well, if it's degrees, it will have a degree mark. Remember, radians are the mathematical unit, so they aren't labeled. There's no need to label them. Everybody knows that angle is a radian. If you want to use the artificial measurement, which is degrees, then you'll put a degree mark on it. So your answer is going to be 16 divided by that.
Yeah.
Yeah. Peter?
What's the thing where it's like pi 180 equals like x over
Okay,
over 6?
so,
What is that?
Yeah, I wasn't real clear on that because you guys have to cut me a little slack. It's like when you do something so many times and it's so like obvious to you, you forget that it isn't obvious to people who are just learning it the first time. So that's, as you kids say, my bad. So yes, let's clear that up. In the notes, somewhere in there, I copy and pasted stuff out of the textbook. And in the notes, they had a conversion to change radians into degrees and to change degrees into radians. If you're looking at my work, I don't do it that way. If I have, let's say, 35 degrees, and I want to know how many radians that is, I'll set up a proportion every time. I'll say pi is the same as 180. These I know are equal. Pi radians is 180 degrees. That will never change. How many radians then is 35 degrees? So I do the conversion using a proportion. You don't have to. You can use the little fractions they give you in the notes if you prefer. Then I cross multiply, so 180x equals 35 pi, and x equals 35 pi over 180. Then I reduce the fraction, and that's it, okay? So I started with 35 degrees, and this would be my radian measure.
So in the next problem,
Yes,
you
right.
would use that?
We use this one
And then that on
for D.
So which one did I just do?
You did
A.
For 4.
For 4B, would you then use?
For
Graph
4B, yes,
Okay.
because the angle, I erased it, but the angle has to be in,
Degrees.
no,
Well,
radians.
degrees to use the that.
Yeah,
Yeah,
well, yeah.
that's what I was-
But actually, this conversion will change anything. So let's say I had 4 radians. And I wanna know how many degrees that is. Pi is to 180, as 4 is to x.
Okay.
Pi radians, 180 degrees, 4 radians, x degrees. Now, this was a little bit of a confusion for somebody this morning. She was concerned about an angle that was a radian measure, 4 radians, and it didn't have a pi. Yeah, they don't all have pi's. Similarly, some degree measures have pi's in them. So you can't make a determination about what kind of angle you have based on pi's. They show up and don't show up in both units. Okay, so I set up that same proportion, radians, degrees, every time I make a conversion of any kind.
Okay. Makes
Okay.
sense.
So is that pi there 180 or?
So that pi right there would be 1.4.
So what's it, how can you tell the difference then? When do you use 180 versus 3.4?
Okay, why are you doing that at all? Let's just remember that pi radians is 180 degrees. And then, we'll just get our
Oh, so then you
answer
never
just like
really
this.
use pi?
Now, I did in this problem, because I had to get like a
That's
number.
180 right there?
Here?
Yeah.
Circumference is 2 pi r. That's 6.28 times pi.
So pi is never 180.
Pi radians, if you have a radian measure, yes. Pi radians is the same as 180 degrees. This is a degree measure, not a radian measure.
How can you tell the difference? Well, obviously the
It's got a
degree
degree
sign,
mark
yeah.
on it, yeah. All right, let's move off that, it's getting confusing unnecessarily. I'm not sure why you're kind of fixated on that. Try to, okay? All right, Lewis?
4.1, number 7.
And everyone else just final.
Okay, we looked at this one earlier, and when I had originally done it, I got a circle with a radius of 25,
No, it's for
and I've got this angle is 42.5 degrees, and this angle is 52, that'd be 42 degrees. Remember, there's 60 minutes in a degree, so 12 60ths would be 1/5. So here are my two angles. And I wanna know this right here. I wanna know the difference between those two arcs. What is the difference between those two? So, the way I did it, when I worked out my answers, I found the pink arc using radius times radians, so I changed that into radians and found it. And then I did the same thing and found the orange arc, and I subtracted them. When we were talking earlier, and since the answer is the purple arc, how about if we just subtract our two angles and find that arc directly? Doesn't that make sense? So the difference in the angles would be what? What's 52.2 minus 42.5? 9.7? Is that right? Now, that's 9.7 degrees. If I am going to find arc length using radius times radians, then I need that angle to be in radians. So, you can do whatever you want. I'll say pi is to 180 as something is to 9.7. So x is gonna be 9.7 pi over 180. That's gonna be my radian measure of that angle. So my arc is going to be 25, which is my radius from the problem, times 9.7 pi over 180. So hopefully I get the same thing I got when I did it the other way. So 25 times 9.7 pi divided by 180. 4.23, yep, that's what I got when I did it before. So 4.23 miles. So that's an arc length problem, Lewis. Don't overthink it. It's an arc length problem.
Is the 30 in that, is that representing their, like, distance or speed? Because it's a 42 is the angle, what is 32?
It's 30 minutes. You need to watch the video. It's 30 minutes, which is half a degree.
Is that-
That's why I wrote 42 and a half.
Okay, is that what like the little mark is?
Uh-huh. All right, one more question, then we're moving on. One more. Anybody have one more from homework?
I think it's 5 on 4.1.
4.1. This is gonna be another arc length problem because it says I have a 10-degree sector. So a piece of pie is called a sector. That's called a sector of a circle. And the radius is 11. And I wanna know the perimeter of the piece of pie. So I wanna know the red, that's the perimeter of the piece of pie. Well, I know it's 22 plus the arc length. So to find the arc length, I know it's gonna be radius, which is 11, times radians, which I don't know. So you do your thing, I'll do my thing. pi is to 180 as something is to 10. So 10 pi over 180, which is pi over 18. So the measure of that arc is 11 pi over 18. So my answer is 22 plus 11 pi over 18. That would be my exact answer. Obviously, I could type 11 pi divided by 18 and get some decimal, but that would be the exact answer.
Which one do you want us to get in?
We almost always prefer exact answers. Now, back here in this problem, we were talking about how many revolutions it makes. Common sense, I mean, if someone asks you that question, you're not gonna say 83 pi, right? You're gonna say 15.5 or whatever it is. So, I'll try to be clear on the directions about leaving things exact. And obviously, if you don't have a calculator, like I didn't need a calculator to do this. This could be a no calculator problem, then obviously you're gonna stop here. And that unit would be inches, yeah. So this is gonna be inches. If you type that in, you get 23.92. Some of you typed it in, so I need you to check. Okay? All right. So now we're going to turn that homework in. I know some of you turned it in and brought it back. Don't forget to turn it back in.
Papers after the crossword, after the bell rang. It was like,
I'm just copying their answers, Kristen.
No, this is calculated when you know my calculator. Doesn't really, I don't wanna leave it on it.
Okay, we need to get that
I know, I need to
situation
get that.
figured out.
What do you like to do with this? Let's say you introduce the new code. I'll take it too.
Okay. We aren't going to go through all of our graphing this carefully, but we are going to look carefully at the sine and cosine. Alright, so here we go. We're gonna graph y equals cosine x. Okay. So first, I'm gonna draw my handy dandy unit circle. And I'm gonna label all of the quadrantal angles. We did this yesterday. So the unit circle has a radius of 1, centered at the origin, so there are my points. I know I'm graphing cosine, so I know that in terms of cosine values, cosine is x over r, right? But since r is 1 in that circle, r is 1, then doesn't that basically mean my cosine values are going to be my x values? Okay. So, on my y-axis, or my x-axis, I'm going to label the angles that I'm going to be graphing. So I've gone a revolution positive. These are the quadrantal angles. You might think of them as 90, I'm doing this backwards, so 90, 180, 270, 360. I'm doing it in radians because we're going to graph, all our graphs are going to be in radians. Graph in radians. And I want a negative revolution. So negative pi over 2, negative pi, 3 pi over 2, 2 pi. And now I'm just going to pull off the x values and match them up with those angles. So at 0, what is my cosine value? Cosine is x. So at 0, it is 1. What is it at pi over 2? What's my x value at pi over 2? pi over 2. What's my x value? 0. What about pi? What's your cosine at pi? -1. I'm plotting these values. These are cosine values. I'm plotting cosine values at certain angles. What happens at 3 pi over 2? What's my cosine? 0. And then at 2 pi, aren't I back where I was at 0? So if I kept going, which I'm not going to, you would see that repeating thing going, right? All right, let's go backwards. What about negative pi over 2? What's the cosine? 0. What about negative pi? What's the cosine? -1. How about 3 pi over 2? What's the cosine? 0 again. And then at -2 pi, I'm right back to 0. So I'm going to connect these dots with a nice, smooth curve. And I want you to tell me if you've ever seen that before. Like in chapter 1 with your BFFs. And remember how we how did we distinguish between the sine and the cosine?
Cosine was
The sine went through the origin and the cosine started up here. Well, isn't that exactly what happened? Cosine is a circular function, like all of them are. All of them are circular functions. It comes directly from the circle. Now, if I used the unit circle in your notes, I could plot a whole bunch more points, but this is enough for me to see the shape. Quadrantal angles are enough. Okay? So that's y equals cosine x. That's it. Now, I want you to tell me what happens when we put a 1/2 or any number in front of the function. Again, think back to chapter 1. What happens to the picture when you put a 1/2 or a coefficient on the function itself? It alters this, right? It does this. So, 1/2 out in front is going to make this thing half as tall as it was. So instead of going all the way up to 1, it's only going to go up to 1/2. Now, zeros don't change because here the height is 0, so timesing it by 1/2, it's still 0. But this one will be -1/2. So this is going to be half as tall as it was. When you have what's called a periodic function, this is periodic. Periodic means it repeats. If I kept going around the circle, I'm just going to keep getting more and more of these waves, right? Periodic things sometimes have what's called amplitude. Amplitude is the height of the waves. So the amplitude of the original cosine is 1, because the radius of the circle is 1. If we stick a number out in front, that number multiplies the height, so it multiplies the amplitude. So the amplitude of the purple one is 1/2. Now, in pink, I'm going to do -2 cosine x. Now, what is the 2 going to do? It makes it twice as tall, right? So instead of going up to 1 and down to -1, it's going to go up to 2 and down to -2. What is the negative part of it going to do?
reflect over the y.
Reflect it over the x-axis. It's going to turn it upside down.
Got it.
it multiplies the y's. It turns you upside down. So, instead of this point being at positive 1, it is now going to be at negative 2. The zeros don't change. So if you're a 0, x-axis, a point on the x-axis, you're not changing. But this negative 1 is now going to become positive 2. And then likewise over here. So the pink one is y equals negative 2 cosine x. Now guys, what's the amplitude of the pink curve?
2.
2! Oh, I love you! It's 2. Amplitude is a height. It's a distance. It's not going to be negative. The negative is important in terms of the graph because it turns it upside down, but the amplitude will always be a positive number. All right? Now, in this exercise, first of all, we reviewed what a cosine looks like. And we also talked about how we change the amplitude of a curve. Have you guys ever looked at a sound wave before? Doesn't it look like this, right? And have you ever heard people refer to as amplifier, an amplifier, right? Guess what an amplifier does to a sound wave? It changes the amplitude, okay? AM radio, amplitude modulation. Those frequencies, actually frequency is not a good word, but it changes the amplitude. Okay, now, next thing we're going to do is look at the sine wave and talk about changes this way. All right, we'll use a sine as our example. So, y equals sine x. Go ahead and label your x-axis with those same labels, quadrantal angles. These are the angles on the quadrants. And we could go around as many times as we wanted, but I'm just going once positive and once negative. That's enough. Now, if we're graphing sine, and we're not going to be plotting x values, we're going to be plotting y values. So at 0, this is 0. At 0, the sine is 0. Aha! We knew that already, didn't we? Yeah. At 90, or pi over 2, the sine is 1, and so on, and so on. I'm running low on time, so I already know what this looks like because I memorized my BFFs. These are the y values. The amplitude of the sine curve is also 1. Would you agree with that? Yeah, it's coming off the same circle, so its amplitude is 1. Now, I can put numbers in front of it to change that, but the standard amplitude is 1. Now, I also want to talk about now the period of the curve. This curve repeats. It's got a hill and a valley, a hill and a valley. If I kept going, another hill and valley, it would just keep going forever and ever. The repeating chunk is called the period. So for a sine curve, it's a hill and a valley. If you cut this much out, you could create the curve by just pasting that piece end to end to end. That's what it means when we say the period is that chunk. how long is a period? In other words, how much horizontal distance does it take to get a hill and a valley?
2 pi.
2 pi. So the period is 2 pi. If you look back at your cosine curve, its period is also 2 pi. And that is not a coincidence. Isn't 2 pi once around the circle? If you go around again, aren't you just repeating yourself? Every time around the circle is going to be a repeat. I know you can't wait to get out of here, but I got one more important thing. We're gonna graph 2 sine 2x. You know what that 2 does. What does that 2 do? It multiplies the height. So we're going up to 2 and down to -2. Now, who remembers what that 2 does?
Multiplies the x.
It divides the period. It divides the period. It divides the horizontal. When we did this before, we talked about this as multiplying the vertical, and this divides the horizontal. So what does that mean? That means that instead of taking 2 pi to get a hill and a valley, now it's only going to take 1 pi. So this is gonna go up and down and end right there. So isn't it gonna look like that? It's twice as tall, but half as wide. So this amplitude will be 2, but the period will be
All right, good afternoon. Good
5.
evening. Sunshine, it's
We'll
3:14.
continue this next time.
Stop where young, please, when you have afternoon prayer, and welcome back to those who are on the junior